Now we know that if we have a pair of random variables, they can be related to each other somehow. They can be dependent on each other. And in such a situation, when the value of one of these two random variables is given, this may also affect the distribution of the other one. For example, let's say that random variables of our interest are weight and the height of a random person. So the weight of a random person is a random variable. The height of a random person is a random variable also. They both have their own distributions. But let's now imagine that we are interested in weights not of all people, but only of people that are 176 centimeters tall. So we choose people at random, but not out of all people we meet, but only out of those with their heights equal to 177 centimeters. And so we can say that distribution of a weight of a random person is the one distribution, and the distribution of a random person that is 177 centimeters tall is the other distribution, different from the distribution of the weight of a person with unknown height. So distributions of this kind, so distributions when we choose at random, but with the fixed value of some other random variable, are called conditional distributions. So let's now look how they are described mathematically. So definition of the conditional distribution is just that it is the distribution of x when y is known to take a particular value. So when the experiment is already done and y realized somehow, so y has already taken some value, and we are now interested in distribution of x. Different notations are used to describe such a situation, but one of popular notations is the one you see now. So law of x given y. So this formula, this symbol is read as law of x given y, or distribution of x given y. So how can we describe such a situation in discrete case? So in discrete case, if we are interested in distribution of x given that y has already taken the value equal to the small y, so we are to find conditional probabilities. So conditional probabilities for all possible values of x. So the distribution of x in discrete case can be described with a table of distribution, as you know. And so in the lower row of this table, there are probabilities. And here, they are not the ordinary probabilities, but conditional probabilities. So probability of x being equal to x1 given that y is equal to small y. Then probability of x being equal to x2 given that y is equal to the small y, and so on. So this is sometimes called the conditional PMF, conditional probability mass function. So and this is a function of two arguments. And for each pair of values, x and y, it is equal to the probability that x is equal to small x and y is equal to small y at the same time. Sometimes this is called a conditional PMF, conditional probability mass function. So this is a function of two arguments, and for each pair of arguments, small x and small y, it is equal to a conditional probability that x is equal to small x, given that y has already taken the value equal to the small y. So we know the formula for conditional probabilities. So P of A given B is equal to P of A intersection B divided by the P of B. So this formula can be applied here also. So this conditional probability is probability that x is equal to small x and y is equal to small y at the same time. So what we see in the numerator is probability of the intersection divided by the probability that y is equal to small y. So that is how this table can be filled. And as you see from the last formula, that to fill this table, to calculate all these conditional probabilities, we need the joint distribution of x and y. So to substitute probabilities that are in the numerator of this formula, we need the joint distribution, joint table of distribution of x and y. Now, what do we have in a continuous case? For a continuous case, the conditional PDF can be defined. So conditional probability density function of x given y. And this is also a function of two arguments. And to find this function, we also need to know the joint distribution, as the conditional PDF of x given y is defined as the joint PDF of x and y divided by the PDF of y, by the marginal PDF of y. So we are to know the joint distribution and the marginal distribution of y to find conditional distribution of x given y. So one of the main numerical values that we are interested in while dealing with conditional probabilities is the conditional expected value of x given y. And so to find the conditional expected value of x given y, we are to know the conditional distribution. So in discrete case, we are to know conditional PMF, these conditional probabilities. And in continuous case, we are to know the conditional PDF. So, and this, as you can see in this definition, so conditional expected value is defined like an unconditional, an ordinary one, but in discrete case, probabilities are conditional. Instead of ordinary probabilities, we see conditional probabilities. And in continuous case, instead of ordinary PDF, we see the conditional PDF of x given y. So, and what does it mean? So, how can we explain what a conditional expected value is? So, this means that we are interested in the mean value, the average value of x, given that y is already known. If we go back to our example with weights and heights of random people, so we can say that if we are interested in the average, in the mean weight of a random person that is 177 centimeters tall, so that means that we are looking for the conditional expected value of x given that y is equal to 177. So mean weight of people who are 177 centimeters tall, mean weight of people who are 152 centimeters tall, mean weight of people who are 191 centimeters tall, and so on. These are all conditional expected values. So conditional expected values of x given that y has already known, and so for different possible values of y. And so these can be found using these formulas. Now we will find the conditional distribution and conditional expected value for the example we have already discussed. So where we have two random variables that are linear algebra grade and calculus grade of a random student. And x can be either 0 or 1, and y can take values 2, 3, 4, or 5. So we have joint distribution. X can be 0 or 1, and y can be 2 or 3 or 4 or 5. And the probabilities are namely 0.2, 0.15, 0.15, 0.05 here, and 0.05, 0.1, 0.1, 0.2 here. So, using this table, we can find marginal distributions of x and y. We have done this already. So x is distributed as follows. It is 0 with probability 0.55 and 1 with probability 0.45. And y is 2, 3, 4, or 5 with equal probabilities of 0.25. So, after we have this data, we can find conditional distribution. Let us find a conditional distribution of y given x is 1. So, conditional distribution law of y given x is 1. That means a distribution of the calculus grade of a random student that passed the linear algebra test. So we are choosing students at random, but only out of those who have passed the linear algebra test. So possible values of y are 2, 3, 4, 5. So we'll have 2, 3, 4, and 5 in the upper row of our table. And here, so we are to find probabilities to fill the second row. So what is this? This is the conditional probability that y is 2 given that x is 1. So conditional probability that y is 2 given that x that x is 1. So according to the definition of conditional probability, this is probability of intersection, so probability that y is 2 and x is 1 at the same time, divided by the probability that x is 1. So we have both probability that that y is 2 and x is 1 is 0.05. So we have 0.05 in the numerator, and probability that x is 1 is 0.45. So, and we have 0.45 here. So it's better to use not the decimal numbers, but fractions here, and this is 1/9. Then, so I have 1/9 here. And now we can easily find the other three probabilities with the help of formulas of this kind. So probability that y is 3 given that x is 1 is probability that y is 3 and x is 1 divided by the probability that x is 1, and that is 0.1 divided by 0.45, and this is 2 over 9. The same number as here, but multiplied by 2. So probability that y is 4 given that x is 1 can be found according to the same formula, and actually its value is the same, as it is 0.1 divided by 0.45, which is also 2 over 9, and probability that y is 5 given that x is 1 is 0.2 divided by 0.45, that is 4 over 9. So 1 over 9, 2 over 9, 2 over 9, and 4 over 9. So this is the conditional distribution of y given x is 1. So this means that if we choose a random student, then with probability 1/4, their grade in calculus is 2, with probability 1/4, 3, with probability 1/4, 4, with probability 1/4, 5. And if we choose only out of those who passed the linear algebra test with probability 1/9, it is 2 with probability 2/9, 3 with probability 2/9, 4, and with probability 4/9, it is 5. So as you see, if we choose only out of those who passed the linear algebra, then probability of getting higher grades is much higher than in general, than if we choose out of all students. So that is how we can find the conditional distribution. Then when we have already got a conditional distribution, we can find a conditional expected value. So the expected value of y given x is 1 is, according to this table, so it is calculated according to the general formula. So we multiply each value by its probability and add this product. So this is 2 times 1 over 9 plus 3 times 2 over 9 plus 4 times 2 over 9 plus 5 times 4 over 9. So, and we can see that this is 2 plus 6, that is 8, plus 8, that is 16, plus 20, that is 36. 36 over 9, that is 4. So average calculus grade for those who passed the linear algebra exam is 4. Okay, so this is conditional distribution when the value of x is given and is equal to a given number. But we can generalize this concept, the concept of a conditional expected value, and to consider an expected value of y given that x is just small x. So we can say that x is either 1 or 0. With probability 0.45, x is 1. And with probability 0.55, x is 0. So when x is 1, so with probability 0.45, expected value of y given x is 4. And now we can also find expected value of y given x is 0. And we can say that expected value of y given x is a random variable, as it depends on the value of x, and the value of x is random. So let's do this. We have already got expected value of y given x is 1. Let's now find expected value of y given x is 0. So we already know that expected value of y given x is 1 is 4. Now let's find expected value of y given x is 0 with the same algorithm. So the first step is to find the conditional distribution. So I need conditional distribution of y given x is 0. So two, 3, 4, 5. So probability that y is 2 given x is 0 is probability that y is 2 and x is 0, that is 0.2, divided by the probability that x is 0, that is 0.55. And this is 4 over 11. Then probability that y is 3 given x is 0 is 0.15 divided by 0.55. That is 3 over 11. Probability that y is 4 given that x is 0 is the same. Also 3 over 11. And finally, probability that y is 5 given that x is 0 is 0.05 divided by 0.55, that is 1 over 11. So here are our probabilities. So this is distribution of a calculus grade of a random student that did not pass the linear algebra test. So as for the expected value of y given x is 1, given x is 0. So this is 2 times 4 over 11 plus 3 times 3 over 11 plus 4 times 3 over 11 plus 5 times 1 over 11. That is 8 plus 9, 17 plus 12, 29 plus 5, 34. 34 over 11. Or, so we have expected value of y given x is 1, this is 4, and we have expected value of y given x is 0, this is 34 over 11. So to unify the notation, let me use the decimal number. This is approximately 3.09. And so the probability of this case that x is 0 is 0.55, and probability of this case that x is 1 is 0.45. So expected value of x of y given x with probability 0.55 is 3.09, and with probability 0.45 is 4. So we can say that expected value of y given x is a random variable that is distributed as follows, with probability 0.55, it takes value 3.09, and with probability 0.45, it takes value 4. So after we know conditional expected values of y for all possible values of x, we can generalize this, and we can say that conditional expected value of y given x is a random variable of its own that can take several values. So, and probabilities for these distribution tables are just taken out of this table. So we just take these probabilities that we see here and move them here. So that is how we can deal with conditional distributions and conditional expected values in discrete case, and that is how we can find the conditional expected value as a random variable. So conditional expected value of y for all possible values of x.